One of the things that was strengthened in the publication of IATF 16949 was the effective use of error proofing. Requirement 10.2.4 mandates that an organisation has documented processes on error proofing. They use suitable error proofing methods that are clearly defined. These are communicated within the control plan and then are effectively implemented and maintained. Let's watch this video filmed at Jaguar Land Rover engine plant in the UK and see what we can learn from how this organisation tries to address this requirement effectively within their quality management system.
Hi Dan, could you just give a quick introduction, your name and how long you've worked here?
Okay, so I'm Dan. I've been at the facility for 5 years, so when it first started.
Okay.
Currently in quality.
Yeah, brilliant. And can you just explain a little bit about what happens within this facility?
Yeah, so at Jaguar Land Rover we have a no faults forward.
Yeah.
Behind me it's a leak test machine up to 10 for cylinder blocks, so we ensure the quality of the product at the end of the line.
Yeah.
In the machine we have a known master bad part and a known master good part. From the control plan it dictates we pick a part out from the machine, and every shift will detect whether it's a bad part or a good part.
Okay, so these blue ones are these the known samples, are they?
Yeah, so the machine, they'll stay in the machine.
Yeah.
And then it'll pick it up at the shift.
Yeah.
And then we'll do a test to see the machine's functioning correctly.
Yeah. And if the leak test does detect a problem, what happens then?
So it'll do the test. If it does detect a problem,
yeah,
it'll be kicked offline, and we will have a problem solving to understand what the fault is.
Yeah.
This process is called error proofing,
yeah,
and we dictate this from the control plan.
Okay, brilliant. Thanks, Dan.
Niall, what do you think were some of the key learning points?
I think the first key point is the importance of the control plan in defining where error-proofing systems are needed. We talk a lot about prevention and risk-based thinking, and the control plan is vital in the management, the day-to-day control of risk. In Annex A of IATF 16949, error-proofing is also included under the methods heading.
Okay, thanks, Niall. And Devon, under the IATF requirements then, what is expected to be defined within the control plan related to error proofing?
Right. So at minimum, the control plan must include where error proofing is used, as well as the test frequency for validating that the error proofing device is indeed working the way it should be.
Yeah, no, I agree with that, Devon. And then Niall, how should an organisation determine the appropriate frequency of the checking of error proofing devices?
Good question. And like many of the items on a control plan, it should be based on a risk analysis that's linked to the process FMEA. And in this video, JLR had determined to verify the devices at the start of every shift. That was their control in this particular case.
Yeah, we certainly saw the use of the challenge parts. Devon, what's IATF say then about how we look after and maintain these challenge parts we use for the error-proofing devices?
As you saw in this video, it's interesting. The process of checking challenge parts was done automatically, which was we don't always see that. So it eliminated the risk of the human intervention. The challenge parts being inside of a robot cage minimized the risk of damage to those parts themselves.
And now, what did we learn then about if they find a problem when they check using the error-proofing device? What did we learn about the action JLR then took?
So the first thing, again, is that the action should link to the reaction plan in the control plan, again, underlining the importance of the control plan as the central document around the manufacturing process. And in this case, the first thing would be to contain the issue, which in the example we saw in the video would be to segregate the production that had been produced on that one shift and then to launch into the problem-solving investigation process.
Okay, thank you. So let's summarize. So as we heard in the video, the JLR methodology is no faults forward at any stage of the manufacturing process, which clearly demonstrates the focus on defect prevention within the station, which is clearly aligned with the IATF goal of defect prevention. The key IATF 16949 requirement related to error proofing is 10.2.4. To verify error proofing is working effectively, it's essential to have controlled and maintained challenge parts. The frequency of checking the challenge parts needs to be based upon risk, linked to the FMEA, and then defined within the control plan.